In this problem, we're to find V0 and V1. Again, this is a circuit that has only one source and a number of resistors. Again, we're going to use our problem-solving strategy for analyzing circuits containing a single source and a series parallel interconnection of resistors. So we're going to start simplifying the circuit until we get to the point where we have a single source and a resistor, and then work our way back. Our first task, though, is to look at this connection and redraw the circuit and eliminate that. So we're going to take this. This is an ideal conductor, so the voltage across here is 0. So we're now going to take all the elements connected here, and we're going to pull them all down to the bottom of the circuit. So let's redraw the circuit first. It'll kind of clear up how things are connected. So now, when we do that, our 20 milliamp source is connected like this. So we've redrawn the circuit to eliminate that one connection. Here's the voltage V1. Here's the voltage V0. Okay, now start off, these two are in parallel, so we can combine them, and when we do that, our circuit will become this. Okay, 6K and 12K in parallel is a 4 kilo ohm. The voltage V1 is still across that 4K resistor because the 6 and the 12 are in parallel. Okay, now what we can do is these two 4Ks are in parallel. Okay, so now let's combine those and redraw the circuit. And if we combine two 4K resistors in parallel, we're going to get a 2K resistor. So here's our 20 milliamp source, 10 kilo ohms, 4 kilo ohms. Here's our voltage V0. The voltage V1 is here in the circuit because that's the voltage across those two 4Ks that were in parallel. Okay, so V1 is at that point. Now, these two are in series, so we can take one more step. So now our circuit becomes this. The 10 and 2 in series becomes a 12K. Here's a 4K. Here's the voltage V0. Now we can combine these two in parallel. And if we do that, those two resistors in parallel, we make the calculation, they become a 3 kilo ohm resistor. Here's the voltage V0. Now, we've got 20 milliamps flowing in this direction. By Ohm's law, that's going to produce a voltage of 60 volts with that polarity. So then that tells us, if we look that V0 is minus 60 volts. Okay, so now we're going to start working our way back up through the circuit. So we have 60 volts with that polarity. So now we have 60 volts here. That tells us that we've got 15 milliamps here. And we would have 5 milliamps here. So in this circuit, we've also got 5 milliamps here. So then that tells us that V1 is 2K times 5 milliamps, or 10 volts.